Hi everyone, I'm Kamla Al Mannai. I work at the ALT group at UCRI. So here today our presentation is how to improve, how to use the unsupervised word segmentation in order to improve the dialectal Arabic to English machine translation. An overview of the presentation, we will start with our goal, which is to develop a dialectal Arabic to English machine translation system. And we faced some issues like the size of the training corpora. And another one is that we lack some of the NLP tools that could help us to develop our statistical machine translation system, like word segmenters. And our solutions are to collect more data and also to develop our own segmenter for dialects. Our segmenter is following the unsupervised approach. It is unique in a way that it could be used to be modified and used for a different combination of different dialects. So before going into details, we'd like to give a little introduction about the dialectal Arabic and how is it different from Arabic. So we could say that Arabic could be divided into dialects, and here are some of the major dialects that are mostly related to the countries that they are spoken in. And the second type is the modern standard Arabic, which is common across the different countries. So the main difference could be, like dialects, we use it in informal communication, but modern standard Arabic, it's more to the formal settings when it comes to writing and speeches. So you could see that we use dialect in verbal communication and MSA in formal speeches and also in writing, but recently we have using dialects in a writing form where we use it in social media and blogs. So this is like the motivation why we become interested in dealing with dialects. So here the problem is that we become very interested in using some dialectal word segmenters in order to improve our statistical machine translation. So when it comes to MSA, people have already worked on it for a long time, and they have been collecting data and building some good tools like the morphological segmenters. But when it comes to dialects, there are many dialects, and we are really lacking to have a tool for each one of the dialect. So here we are trying to come up with a better way an easy way to develop a segmentation tool that could be used for each dialect or even for a different combination of the essential dialects. So here we will hear a little description on why we really focused on developing a segmentation tool in order to improve our machine translation system. So you could see that we have, for example, when we pass the data to our machine translation system, it starts to align between the Arabic and English word, but the problem is that we have words in Arabic and they are aligned to phrases. So we have like Beitna, which goes to our house, and then Beithom, which go to their house, Beita, his house. And so here you could notice that Beit should be aligned to house, but the problem is that because we have this one-to-many alignment, the system is failing to really find the translation for the root word, which is Beit. So it's considered as an out-of-vocabulary word. So segmentation could be really helpful for this problem, which we can get a one-to-one alignment, and it could reduce the symptoms of having an out-of-vocabulary words. So we get the Arabic words and we do the segmentation, then we pass them back to the machine translation system in order to get a better alignment, and we end up having a new phrase table where we have a one-to-one alignment, and we solve also the out-of-vocabulary words problem. So here our goal is to create so here we focused from the different dialects to create the machine translation system to translate between the Qatari Arabic into English. So first we run our, this is the first Qatari Arabic to English machine translation system, and we run our baseline experiments, which we got a 12.2 blue score. Then knowing that segmentation should improve the machine translation quality of our system, we started with using an available segmenters, which are mainly designed for modern standard Arabic, and we get some improvement, which is an 0.7. Then we decided to go and build our own segmenters for dialects. So there are many different approaches. We could follow the rule-based, and which need data and need some linguists in order to derive the linguistic rules. The other solution is to use the statistical models, which either using a supervised or unsupervised, and both of them, they need data, but the supervised might need also an annotated data in which we give the right segmentations. So we decided to go with the unsupervised one. So our goal is to build a word segmenter for Qatari Arabic. We started with collecting data, and here we collect data on a sub-dialects level. We found data for all of the Gulf sub-dialects. We really focused on the Qatari data, and all of these data are collected from the web, and they are mainly novels, so they are really have very purely dialectal content. They don't have a lot of MSA words unless it is part of the dialect. So next, we use the collected data in order to train an unsupervised morphological segmentation model. We use Morphosor categories map toolkit as a black box, where we pass the input and we expect the output as a segmented words. So the Morphosor is having only one hyperparameter, which is called the perplexity parameter, that controls the segmentation rate. So for Arabic, we found that the value 130 is the value where we have no segmentation. So we were trying to find a value between 0 and 130 in which it optimized the machine translation quality. So here, after training Morphosor on the data collected, we get an improvement with 1.5 over our baseline. So up to here, we are only using an unsupervised segmentation trained on the data collected. After that, we really become interested in using the same setup to create segmenters for combinations of other dialects. So focusing on our Qatari to English machine translation system, we are interested in improving the quality by using resources in other dialects. So we collected data mainly from the major dialects, MSA, Levantine, and Egyptian, and then we train a multi-dialectal segmentation model. But the difference here that before we have only the Qatari data, and now we have Qatari data with other dialects. So one problem could be the difference in sizes. For example, the Qatari corpus is very small compared to the MSA corpus. Therefore, we scale the data in order to be equal, so we make sure that no corpus over-dominate the other, and then we combine them and we pass them to the Morphosor as our training data. We end up evaluating our multi-dialectal segmenter by passing the segmented data to our Qatari to English machine translation system. So you can see that we add MSA to Qatari, Levantine, and Egyptian, and we try the two types of segmentation compared to having no segmentation, and our multi-segmenters is really providing a consistent improvement of 1.5 in blue points. So our main contribution is to build the first Qatari to English machine translation system. We collected some monolingual data that could be used for developing segmentation tools or for other applications, and we'd like to try our segmenter in other applications and to improve our Qatari to English statistical machine translation system. So thank you.
Thank you, Kamla. Could you go back to your experimental results and tell us a little bit more about what is the baseline and what is the testing? Because I think I missed that part.
Okay.
How many sentence pairs were in your test set, and what's the genre? Because
Okay, so in our baseline, yes.
yeah, the data size and how much training data did you have?
Slide 18.
Okay, yeah. Okay, so for our baseline, we used an available corpus, which contains 14,000 sentences. We used 1,000 for development and 1,000 for testing, and the rest for the training.
From where did you get this Qatari?
So we get it. It's already published by people at Qatar University. Yes. Yeah.
Should be the Qatari corpus translates from speech, right?
Yes.
So when you, for the second condition, ATD, how did you get the Arabic Tree organization?
So here we use the Stanford segmenter.
Is the corpus available?
The one for the baseline?
You used here for your
Yeah, yes. Yeah.
You try just to use available MSA data to translate as a baseline in Qatari dialect, just without doing anything.
Yes.
Just take Arabic text and MSA text and
Yeah.
translate.
Yes. So here, the first part.
Without Qatari,
Yeah. So from MSA to English, you mean?
yeah.
No.
To translate your.
Our Qatari system. Okay, so yes, before we tried that, but it's not really over the baseline, the result that we get.
Okay, and about your slide number 20, how you scale your data?
Okay, so here, so we have, for example, when the Qatari is smaller in the number of tokens than MSA, so we just multiply it n times in order to be equal in size.
Kind of purpose rating.
Yes.
When we deal with very small data,
Mm.
sometimes we cannot generalize risks. In a similar situation in machine learning and language modeling, cluster language modeling gives very good results for small data. Once we go to large data,
Mhm.
it disappears. The effect disappears. So try to use large data.
Can I add to this? So the first thing is like that's the minimum which was maximum which was available at the Qatari English letter which is available, like which we use, that's the max which you can get. And the second thing is when you add MSA, which is like about more than 300,000 sentences, you still see a gain. So I think you find that actually keep on going there. Many of the games that you get, they have been issues. But I'm still like,
The practical point is when the new scale is not reliable on that system. So you have to do real large data, not to stand on something reliable. Once you go to this large data, the results will make difference. the idea is good. We still need to test it, but testing it cannot data will give us more sense about this effect.
Yeah. Question about the collective knowledge.
Mhm.
Are they all written in dialects, pure dialects?
Yes, yes. Like they are they are unofficially published.
Or some parts of them, for example, some dialogues between.
Actually, because they are romance stories, so they are very consistent in being written in dialects.
One last question about your results in the last part.
Okay.
So, yeah, what's the difference between Qatari plus NSA and Qatari plus Dialectal in the no segmentation and the ATV conditions?
Okay, so we can concatenate the corpora from both dialects, from Qatari and MSA. Then we apply, we have no segmentation, then we use the ATB segmentation, then we use our Merfessor-based segmentation scheme.
But I thought that you were concatenating this data to tune your Merfessor.
Right.
So how does that change the no segmentation?
So here we are evaluating using our Qatari machine translation system when we adapt resources from other dialects.
Just one last question. So you said you had a collection of different novels from different parts of the Gulf, so including Bahrain, right?
Right.
So are those
Yes, they are.
Okay, one more question is, was it transcribed or like as a
No, they are.
narrative or was it written?
They are written in Bahrain.
I would like to learn more.
Sure.
I have one question about your system. Actually, when we have a limited amount of data, what is usually done in machine translation is to do an unsupervised method to generate data. So you can translate a lot of all MSA data using your small system
Yes,
to
sir.
get close to Qatari data to train your system.
Okay. Yeah.
And try and compare.
I'm afraid this is not so possible because unlike the previous work where you have actually parallel MSA direct data, here this is not the case. Here you only have data between, you don't really have parallel data between the MSA and dialects. You only have, a dialect. You have dialectal data and you have English data, but then you don't really have MSA dialects, and you cannot really do this. I mean, you can do it purely from an English to go from English, not very well.
To use English and direct in Qatari to translate English part.
Yeah. Actually, maybe another question, just a question that we have actually parallel, I don't know if that's the right expression, dialects, words.
Yes, we do. Actually, we have written with Nizar at CMU as a pilot study, multi-dialectal courses covering 5 dialects and English and MSA. It's quite small for now, but the project will start soon and we will make it bigger. But this small amount of data is already available now. So if you want it, just email me and I can give it to you.
Does it take a word that is used in multiple languages and say what they differently mean, or does it?
I have it at the sentential level, actually. I have the sentence, exactly. I have a Tunisian sentence with its Egyptian sentence, Palestinian, Jordanian, and English and MSA.
Okay, I was thinking about something. Well, maybe we can get to it. If you use, for example, the word mahdoum. The Lebanese mahdoum means one thing,
Any mistakes?
and MSA means something else, and then in Gulf, I think it's something else. That time actually, what those dialects, mean to MSA is also going to be there, or not?
Not now, actually, we need the project to start.
Is that when we do our?
And these are, and then that's one of the goals of our project, by the way.
So